Everyone, welcome to my presentation in the first international conference on sustainable energy and advanced materials. My oral presentation is titled by Characterization of Soil Pyrolysis Biochar from Date Palm Residues with the aim of the soil amendment. Biochar production and use are part of modern agenda to recycle wastes and retain nutrients, pollutants, and heavy metals in the soil and to offset some greenhouse gas emissions. Biochar has the potential to produce farm-based renewable energy in an eco-friendly way. Specifically, the quality of biochar depends on several factors, such as the type of soil, metal, and the raw materials used for the carbonization, the pyrolysis conditions, and the amount of biochar applied to the soil. This study investigated the biochar production by slow pyrolysis at 400, 500, and 700 Celsius degrees from date palm residues under oxygen-limited conditions for 2 hours. It has been reported that biochar obtained from the carbonization of organic waste can be substituted that not only influences the sequestration of soil carbon, but also modifies its physicochemical and biological properties. The type of biochar produced depends on 3 variables: the biomass being used, the temperature, and the rate of heating. High and low temperatures have an unequivocal effect on carbon yields. This study compares the physical and chemical characteristics of biochar produced by slow pyrolysis. The physical and chemical properties of biochar contribute to its function as a tool for managing the environment. First, we will start by the XRD diffractions. The XRD diffraction pattern of biochar as 400 sample. The XRD diffraction pattern of biochar as 515 sample. And finally, the X-ray diffraction pattern of biochar as 700 sample. After that, we have the after-year spectra. The after-year spectra of biochar as 400 sample. The after-year spectra of biochar as 550 sample. And the after-year spectra of biochar as 700 sample. The biochar produced at high pyrolysis temperature indicates an increase in aromaticity and a decrease in polarity. By using XRD and after-year analysis, it can be concluded that increasing the cellulose loss and crystalline mineral compounds increased. We have some other physical-chemical characteristics such as ash percentage, volatile matter, fixed carbon percentage, yield, sodium amount, potassium amide, calcium amide, and finally chloride amide. The pH values and the electrical conductivity were measured too. The morphological properties of the produced biochar play an important role in their environmental application, which resulted in 634.371 square meter per gram, 818.703 square meter per gram, 928.91 square meter per gram as the specific surface area of S400, S550, and S700 prepared biocars, respectively. As a conclusion, the pyrolysis temperature has a strong effect on biochar properties. Therefore, a biochar can be produced by changing pyrolysis temperature in order to better meet soil application, by contributing to the nutrient statue and iron recalcitrance